So in this first problem, we have a polynomial p, which is graphed below. And what I would recommend doing to figure out this equation of p is to first start by finding out when the polynomial is equal to 0. So we can first determine the numerical value, and then we can think about its multiplicity. And for this one, it looks like when x is equal to minus 3.5, which we can write as a fraction as minus 7/2. This one is when x is equal to 0. And this one right here is when x is equal to 3. Now, going back to that concept of multiplicity, we know that when the function comes down and just touches the graph and then turns around, that's going to be our even multiplicity. And looking at our answer choices, notice that the highest exponent in each of these is 2. So we don't have to worry about degree 3 or degree 4 or above multiplicity. We can just focus on multiplicity of 1 or 2 for now. So at x equals 3, we would say that this has multiplicity of 2. Since, again, it comes down and it touches, but it does not go through this x-axis here. Since if it goes through, like at 0 and minus 7/2, we know that's odd multiplicity. In fact, these behave like lines if you look really close to these points. And so it's going to be multiplicity of 1. If you want to write that, you certainly can. We'll just say m of 1 just to keep it short. And same with this one. This one has multiplicity of 1. Now, when we actually try to create the equation for this, so we have the polynomial p, which is a function of x. We first want to write it as a product of its linear factors, and then we'll determine how to deal with the multiplicity at the end. So for this first one here, this one's a little bit complicated. So what I would recommend doing, if you're not sure how to get the linear factor, is to start with the equation that x is equal to minus 7/2, and then essentially undo the equation and set the equation equal to 0 without any fractions. So let's start by multiplying each side by 2, and then adding 7 to each side. So you get 2x plus 7 equals 0. So that's one of our factors. And you can see that this makes sense because if you plug in minus 7/2 here, the 2's would cancel, and you get minus 7 plus 7, which is 0. So this one makes sense. This one is when x equals 0. So if you want, you could write x minus 0. But really, you can just write x for that factor. And for this last one, we have 3. So we'll write that as x minus 3, since if you plug in 3 here, you do get 0. Now, since the first two zeros are multiplicity of 1, technically we could raise these each to the first power to indicate that fact. But usually we won't write that. Since if you don't see an exponent, you can just assume that it's raised to the first power. Now, for this 0 of x equals 3, since it has multiplicity of 2, we would need to put a square here, since this is really what we would call a double 0. Or 3 is technically the solution to this twice, because if we wanted, we could write this as x minus 3 times by x minus 3, but usually we'll just write it squared. So with that in mind, let's look at our answer choices and see which one makes the most sense. So we know we want x and 2x plus 7 to the first power, so that would be this one, and then our x minus 3 is squared, so it looks like D is the equation that makes the most sense.